Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a C-Cl bond breaks, the chlorine can depart as Cl, electrofuge, Cl, nucleofuge heterolytic with electrons going to carbon, or Cl, homolytic. The key is determining which mode is favored by the stability of the resulting carbon species or chlorine species. Moving on to the next step. Identify the structure. The compound is tricyclopropylcarbenyl chloride, a carbon bearing 3 cyclopropyl groups and 1 Cl. This is the central spirotype carbon. Moving on to the next step. Consider heterolytic ionization. If Cl leaves as Cl, the carbon becomes a carbocation, tricyclopropylcarbenyl cation. This cation is extraordinarily stable due to the well-known cyclopropylcarbenyl cation effect. Each cyclopropyl group provides strong homoconjugative, bisected orbital stabilization to the adjacent carbocation. With 3 cyclopropyl groups, the resulting carbocation is exceptionally stable among the most stable carbocations known. And for the final step, because the tricyclopropylcarbenyl cation is so exceptionally stable, the ionization C-Cl carbocation plus Cl is highly favored. The driving force is the enormous stability of the resulting carbenium ion. Evaluate other options. Cl would require the carbon to become a carbanion, tricyclopropylcarbanion, which is not stabilized and thus unfavorable. Cl, homolysis, would give a carbon radical, which is less favorable than the highly stabilized carbocation. Cl superscript 2 is chemically unreasonable. Therefore, Cl is liberated most easily as Cl, with the carbon retaining the bonding electrons to form the highly stabilized tricyclopropylcarbenyl cation. Therefore, the correct answer is B. Therefore, the correct answer is option B.